Come on, recording. Work this time. All right. What's the first thing we check for Bernoulli trials? Awesome. Success and failure. Okay. What's a success in this problem? Made the shot. So shot made. And a failure? Shot missed or not made. Perfect. Number 2 is checking for a constant probability of success. That's the letter P. So what am I going to use for P in this problem? Very good. So we're basically saying that over a season where he shot 359 three-pointers and then had that three-point percentage, we're going to use that for the playoffs that year. So a constant P. Okay, number 3, the last one. Independent trials. It's just Catherine, don't worry about it. Okay? So if he comes down the court and he shoots a 3 and he makes it, comes down the court again, shoots a 3, does how he did on the last one affect the next one? Actually, I know you're going to like this, but they actually did a study on this with the 1996 Philadelphia 76ers, and they proved that there's actually no hot hand. All right? If you watch sports, like, oh, give it to him, he's got the hot hand. Right? They actually proved that's not a thing. So actually, this is independent. All right, I'm feeling it. Give me the rock. Nope, not a thing, man. Not a thing. Not a thing. I'm going to shoot it. But thanks. Okay. What is the expected number of three-pointers that LeBron made during the playoffs? Well, the first thing I need to ask is, how many three-pointers did he shoot in the playoffs? In the playoffs. Playoffs, 70. You did, Leslie. You're good. I got you. I got you, Leslie. I just want to see if anyone else will say wrong things. All right? 70 shots, three-point shots, I should be clear here, 70 three-point shots in the playoffs. So, yes. I am recording this, yes. Great. Do you want to listen to my child crying in the background? Say, Daddy. Okay. Now, what's the probability? What's the probability of success? 0.315. Okay. Now I know it's been a while since we talked about this, but this is a binomial distribution. And if you go back to your notes from yesterday, these are the notes from yesterday. There they are. Does everyone see the binomial model? And you'll get these formulas. Don't worry. You see here it says mu. That's the mean, the expected number. It says take the number of trials and multiply it by the probability of success. All right, so that's going to be 70 times 0.315. Okay, and then you can use the yellow calculator to get the number of three-pointers that we expect LeBron to have made during those playoffs. Will that be the number he made? Probably not. But that's the number we expect him to make or have made during those playoffs. What'd you get? 22.05 three-pointers. So, again, he can't make 0.05 of a three-pointer. All right, so we've already talked about how expected values will many times not even be a possible value. All right, but we're expecting to make about 22 threes in those playoffs. All right? Now, it also asks for the standard deviation for those three-pointers during the playoffs. Remember that formula for the mean? Well, right next to it was the formula for the standard deviation. And again, you will get these formulas. The square root of n times p times q. We haven't talked much about q. You guys remember what q is? Very good. It's always the 1 minus the p, which is what Leslie did earlier. Okay, so we have sigma, the square root of n times p times q for standard deviation. That equals the square root of 70 times 0.315. And then who has q? Probability that he's going to miss a three-pointer. What is it? 0.685. Great. And use your calculator to find the standard deviation. Did you say something, David? I'm sorry.
No.
Okay. All right, looks like some people are calculating. 3.89. Now, what's really nice, guys, is you already have 3 pointers here. You don't have 3 pointers squared because you notice in the formula it already has the square root. So you've already done that square root part. Don't have to worry about the variance here. Okay? How's everyone feeling about using those formulas? Because you're going to have to use them. I would say the hardest part every year when I teach this is students they have these formulas, they just don't know when to use them. Okay, so on Tuesday, we'll try to find examples in the multiple choice questions. We're like, oh, that's binomial. That's what I should be doing this. Okay, number of successes out of number of trials, binomial. All right, the last part. He actually made 18 three-pointers, which is below what we thought he would make. We thought he'd make about 22, so 4 less. And the media, they criticized him. All right, are his 18 three-pointers unusual considering his regular season field goal percentage for threes is 31.5%? Now that question, unusual. When I read that in stats, I'm thinking about standardizing. All right, do you guys remember a long time ago we made those bell curves? And I told you that almost all of the data values will fall between -3 and 3 standard deviations above and below. So when I see a question that says, is something unusual, I'm thinking, let's get a z-score. Let's standardize. Now, that means we're going to be using what model if we're talking about z-scores? Normal. And if you remember from yesterday's lecture, when you look at the notes from yesterday, we can use the normal model for binomials as long as we check this condition called the success failure condition. So basically, do we expect to see 10 or more successes and failures? So let's check that for LeBron. Okay. Do you remember what you calculated in part B for successes? It was n times p, 70 times 0.315. I believe it was 22.05. Okay? Is that 10 or more? Yes. Let's check failures. Failures is always the number of trials, n, times q, the probability of failure, which you guys already told me was 0.685. So what's going to be the number of misses or failures that we expect LeBron to have in the playoffs? Very good. And what do you notice about that number? It's 10 or more. It's good. It's above 10. That's most important. But 10 is okay too. Okay? Now, every year I get students that realize once you find one of them, you can just subtract from the total number of trials, right? Because these have to add to 70 to n. Okay? So we check this condition. That's called the success failure condition. It's been checked, which means we are free now to use the normal model, which is mu and sigma. Okay, now we already have these guys. We've already calculated them. What was our mu?
22.0.
Excellent. And what was our sigma from part C? It was 3.89, wasn't it? Okay. So now it's like, all right, another formula you got to know. Let's see. Does anybody remember the formula for standardizing for z-scores? You're right. That was so good. Don't. That was so October. Oh, well, here it is for you. All right. It's y minus mu over sigma. Nice job, Travis. Got it at the end. Don't worry, there'll be a formula sheet for the midterm too. Okay, so let's find Z. Who knows what we're going to put into the letter Y? That's the number of shots he actually made in the playoffs. 18, very good. How many shots did we expect him to make? That's the mean, 22.05. And the standard deviation we calculated for those shots, 3.89. So I know it's going to be negative, right, because he made below what we thought. So I know the number's going to be negative, but I want to know, is that number past -3? That's what I really want to know. I don't think it is, but what is it? -1.04. Guys, that's not, it's just, that 18 that he made, 18 shots, is barely past one standard deviation below the mean. That is not unusual. All right, so when they're saying the media is criticizing him, at least when it comes to the three-point percentage, should they be criticizing him for his three-pointers in the playoffs? No, because that is not unusual. They can criticize him for other things, but in terms of this data, yes, he made below what we expected, but nothing out of the ordinary. That's right, you 2007, 2008 commentator.